Take a look at the probability distributions of two experiments. In the first distribution, the possible values of random variable x are 0, 1, 2, and 3. Their respective probabilities are 1/8, 3/8, 3/8, and 1/8. In the second distribution, the possible values of random variable y are -1, 0, 3, 5, and 6. Their respective probabilities are 2/8, 3/8, 1/8, 1/8, and 1/8. Let's calculate the mean of the random variables in both the cases. The mean of random variable x in the first distribution is 1.5. The mean of random variable y in the second distribution is 1.5. Observe that both the distributions have the same mean. However, it does not give us any information about the variability in the values of the random variables. To understand the variability in the variables, let's draw two graphs using the distributions by taking the values of the random variables along the x-axis and their probability along the y-axis. From the figures, it is clear that the spread or scatter of the values of x is uniform, while the spreading among the values of y is not uniform. In statistics, we know that variance is a measure of the spread or scatter in data. Similarly, variance can be considered as the measure of the spread of the values of a random variable in a probability distribution. In a probability distribution of random variable x, the variance of x is given by the formula sigma x squared, which is equal to the summation of xi minus mu whole squared multiplied by p of xi, where I is running from 1 to n, and x1, x2, x3, and so on till xn are the possible values of x, and they occur with the probabilities p of x1, p of x2, p of x3, and so on till p of xn respectively. Mu is the expectation of x or mean of x. The formula can also be written as sigma x squared is equal to e of x minus mu whole squared. The square root of the variance of random variable x is called the standard deviation of random variable x. The formula for standard deviation is shown here. Now, we'll find the variances of the given probability distributions as follows. The variances of the probability distributions are 0.469 and 6.749. This implies that the variance of random variable y is more than the variance of random variable x. Thus, we can say that the spread of values is more in y than in x. Let's review the formula for the variance of variable x again. Now, we'll expand xi minus mu whole squared. On simplifying, we get the expression as shown. Since mu is a constant, we take out mu squared in the second term and 2 mu in the third term in the summations. We know that the sum of the probabilities in a probability distribution is 1. The mean of a random variable is equal to the sum of the products of the possible values of the variable and the probability of their occurrence. Thus, the expression becomes as shown. On substituting the formula of mu, we get this expression. Let's represent it in its function form. Therefore, the variance of x is equal to e of x squared minus the square of e of x. This is the alternate formula to find the variance of a probability distribution.